Basic data literacy for AI reporters. Data plays a big role in artificial intelligence. In this module, we will cover many aspects of data in the realm of AI. We will learn about how data has evolved in recent years. We will discuss the role of data in the realm of AI, and then we will look at 3 examples of the use of AI in data. We will look at structured data that is feeding decision-making algorithms, longitudinal data that is fueling your social media timelines, and text data that is used for large language models. To better understand just how much data exists in the world, let's start with a simple exercise. Look at this image, and then based on the X post, guess what kind of data points a reporter might be able to extract from this post. By looking at the post more closely, we can now see that each post contains a lot of data, not just the text or images of that particular post, but also other metadata, such as a date or the number of comments that a post received. Now look at the same tweet, but structured through an API, an application programming interface, which you can imagine like a data stream that companies use to feed their websites with content. What you see in this image is the same data shown in the X post, but structured as a data object. You can find the same information that you saw in the visual rendering of the post text, the date, the shares. But beyond that, you can also find much more information that is not visible at first, like the platform from which the post was posted. This is the kind of data stream that powers much of the internet. If you think about it, a lot of what we see online is data that is rendered visually. Now multiply that by millions and billions of social media users who are producing content every minute. This might seem like a silly exercise, but it can help you better understand that the World Wide Web, and especially social media, is fueled by data. We may experience social media one post at a time, but truthfully, it's billions of data points produced by people around the world. What happened to data? To better understand how we got to the data-driven world that we are in, let's look at the most recent relevant developments in the field of data. Data has gone from analog storage to digital storage. With that in mind, it's important to know that data collection has not just grown steadily. The past few decades have seen exponential growth of data collection and storage. But much of the latest developments are about data that is collected about people's behavior. Our digital footprints are massive. 1.7 megabytes of data are created every second for every person on Earth. The same amount of data needed to store an 850-page book per second. You yourself produce data on a daily basis. In this experiment from the Wall Street Journal, reporters simulated having a typical pizza party. They found that by using their phone and smart devices to order and deliver the pizza, they gave up 53 pieces of information to companies. To give you an idea of how much data there is out there, look at these warehouses. These are just a few of the warehouses that are used to store data of users' behavior. Every action we take, whether it's public actions like posting a comment on a post, or whether it's actions like searching for a name on Facebook, each action is a data point that is recorded and kept on servers in these buildings. Data is also incredibly important in doing business in the future. We just have to take one look at Meta, a company worth $941 billion, not because of how fun the platform is, but because of how much longitudinal data it has for its 2.9 billion active users. Now that we have an idea of what's happened to data over time, let's connect the dots back to AI and let's ask ourselves, how does data factor into AI? To better understand the role of data, it could be useful to remember the life cycle of AI. In this diagram, you can see that in very basic terms, data is processed and analyzed by an algorithm or model and then spits out an output. This output can be a score, like how likely a photo represents a specific person, or it can be a picture, like this photo of the Pope wearing a puffer jacket. The data underlying these artificial intelligence tools is changing our society. It's changing our job market as chatbots like ChatGPT are automating many tasks for workers. Data is also fueling how governments make decisions. In this example story, journalists at Lighthouse Reports examined an algorithm that the city of Rotterdam was using to determine how likely people were to commit welfare fraud. The data that the government used to determine this included information about people like their gender and whether they were in relationships. But that raises questions. Is a person who is not married more likely to commit welfare fraud? There's also bias in what data is used to train AI. A report from Mozilla found that during the evaluation process of thousands of models, none of them used data from Africa to test their performance. This begs the question, who is this technology primarily built for? Let's now go through some more concrete examples of how data factors into AI. Hopefully, this will help you get a better understanding of how data then connects to real human beings. In this AI Accountability Network story, reporters looked into a system that assigned families a unique ID and a massive data set that the government used to determine whether people were eligible for welfare. Despite the government insisting that their data was accurate, reporters found a man who was denied welfare benefits because he was labeled as dead in the data. Another way for us to look at data is to understand how longitudinal data of our behavior, meaning data that has been collected about us over time, is used to curate our social media timelines. Facebook uses a lot of information and data from you to determine what you see on their platform. To get an idea of how much data they have about you, you can just download your personal data archive. Just looking at the folders alone can give you an idea of the scope. Facebook uses a lot of this data to feed their algorithms. In this story from the Washington Post, reporters found that thousands of data points are used to determine what posts end up on the top of your feed. Since 2018, the algorithm started favoring content that was liked or posted by friends, that was viral but also divisive content. This means that for people who already have strong political leanings, these timelines became a lot more divisive. One last example for you to consider when it comes to data is text data and how it is used in natural language processing. Natural language processing is the process of turning words into data and analyzing it for patterns. You have already encountered this in the wild. Every time you Google something and you see an autocomplete, that autocomplete came from the company using natural language processing to analyze millions of searches and suggesting the next word in your search query based on this analysis and other metrics. These are some concepts that may help you understand natural language processing: a corpus, tokenizing, and stemming or lemmatizing. A corpus, or in plural, corpora, or a text corpus is a large and structured set of texts. Tokenizing is the process of splitting your corpus into subsections. This could be phrases, sentences, or words. It's a way for preparing text so you can analyze it. Once you have tokenized the corpus, you may need to prepare it even more to be able to analyze it. Stemming usually refers to a crude process that chops off the ends of words and often includes the removal of affixes to normalize a word. Lemmatization usually refers to doing things properly with the use of a vocabulary and analysis of words, normally aiming to remove inflectional endings only and to return the base or dictionary form of a word, which is known as the lemma. For instance, the lemma of I am, you are, she is be. The lemma of car, cars, or cars is car. If you look at the token saw, stemming might just return S, whereas lemmatization would attempt to return either see or saw, depending on whether the use of the token was as a verb or a noun. Once you've prepared your corpus into tokens, either as stems or lemmas, you can then analyze the text. This could include creating lists of words that are used the most, predicting which words are most likely to follow one another, just like in the Google search, or detecting sentiment in a text. Thank you very much.